RAILUP, the future mobility podcast with innovators and leaders of the ecosystem. Presented by Sebastian Sperker.
Today I'm delighted to welcome two visionary guests, Alex Peiffer and Timothy Luchini, the dynamic founders of Intramotive, an innovative rail tech company from the US. We will explore their groundbreaking approach to retrofitting standard railcars into cutting-edge, self-propelled, autonomous, zero-emissions machines. We will discuss the significant potential of using the autonomous mode of the upgraded railcars for short distances and last mile and their integration into efficient long-haul services. We will talk about the vision and products of Intramotive as well as their global ambitions. I'm inspired by how Alex and Timothy, friends since childhood, collaborated with experts from space, defense and automotive industry to establish the remarkable company. Join us live from St. Louis today's episode. I'm thrilled to have them both with us today. Welcome to RAILUP Podcast. Welcome Timothy. Welcome Alex. It's great that having you in my podcast. And today it's the first time that we have two guys in my podcast. So welcome and greetings to St. Louis.
Yeah, thanks for having us. It's great to be here and glad to make history being the first tag team podcast here.
Yeah, it'll be kind of fun to put this together. And I know Alex and I haven't gotten a chance to have our conversations shared publicly. So we're excited to dive into the building of this business.
I start my podcast always with the same question, and maybe with Alex, are you more an innovator or a leader?
Yeah, it's a great question. I think it's not maybe mutually exclusive to be an innovator or a leader. So I think, we're not the only player in the rail space trying to innovate, but we do feel like we're leading with the approach that we're taking with the retrofit approach and more of a backwards compatibility with the existing rail system. And we're the first, to our knowledge, to deploy our technology to in a production setting to a paying customer. So, and that's something that we can kind of announce today as having completed our first production delivery of a Revolt vehicle to our customer Iron Synergy here in the States in Pennsylvania.
Okay, great. And what about you, Timothy?
I agree completely. They're not mutually exclusive. I do think we're leading in an industry here where they've been incrementally improving on a tech stack from the 1800s, where at that time the smallest engine you could make was a power system the size of a locomotive. And what we're doing now is taking the new innovations that are coming from small motors, small power systems, small control systems, and leading how we implement those into the rail industry. And we made great progress and excited to continue sharing that.
Okay, great. Then let's start our journey of today. And yeah, as you hear, we're in St. Louis. We're back in the US railway market where the trains are super long and super heavy, where the freight business is very profitable, and where the rail has the biggest share in the modal split. But if we take a look in the numbers in terms of utilization of the assets, the speed of and the predictability, as well as the secondary network, there are still huge opportunities to increase the share of rail, and of course some challenges that needed to be tackled. And today we will speak about a company, about Intramotive, which is located in St. Louis, and we will discuss one of my favorite topics about autonomous, self-propelled, zero-emission railcars. And however, this time we will speak about a different approach compared to parallel, and I'm eager really to hear about the vision of Intramotive. But let's start with the first overview of the biggest challenges in the US market, railway market, and later on to discuss the solutions with the two founders, Timothy and Alex. So, what are the predominant issues in the rail ecosystem, especially in freight transport?
Oh, great question. And here we've got the dichotomy in overland transportation, where we're looking at trucking on one end and we're looking at rail on the other. And really that's a challenge between what's the fastest, what's the most flexible solution, and then what's the most cost-effective side of that. And the same point for the tech stack that they're working with. The rail system's pushed forward for 200 years, getting 1% to 2% better per year. And really where we see the challenge for the industry is how do they grow? And without technologies like ours or adopting new technologies, I think It's a huge challenge to achieve that growth. And we think that the way to do that is to take that profile of a long train, build something that's backwards compatible with that long train, but can still get down to single carload values where we can service a customer, service a shipper, and then take advantage of what that rail system does so well, building these large trains, moving large amounts of materials across the countries very efficiently and flexibly. And Alex, I don't know if you want to add on there.
I think you hit it perfectly. Growth is really the name of the game at this point in the industry, and something that's been hard to tackle for previous decades. And I think getting those unit economics of short trains to be similar to those of long trains, that's really the key to that growth is making, down to single carload profitable. And we need technology to do that. It's not just going to happen with sheer willpower or kind of announcing it as a goal. There has to be a real actionable way to implement that, and something has to change in order for that to happen.
Okay, so the crucial point you just mentioned is growth. And in order to achieve further growth, you need to integrate the first last mile of the secondary network with the long-haul trains. Is that right?
Yeah, absolutely. We got to be able to connect the spurs more effectively and efficiently into those hubs as we aggregate larger trains and bulk transit across to the next hub and then broken back down.
Is it then to really connect like the industry location at itself, or is it also to link the truck with the rail as well? Or is it just purely then aimed to be on rail, the transport?
Yeah, we obviously know that rail and trucking will have a future that goes forward together. It's just really a question of how much is going by one mode or the other. And I think that from our perspective, the freight systems of rail offer a pathway for a lot of growth, getting those trucks off the road and doing as much as possible by rail. And then you look at that last mile delivery or local delivery or something else that might still be done by a truck. But at the end of the day, we see a huge opportunity to take advantage of the rail systems that have been invested in and use them better and get more material through them.
I think also you'll see this trend of, if we can make rail more reliable, more effective, businesses will locate preferentially along rails. Right now, they maybe have the incentive to have good highway access and good access for trucking along the interstate highways, especially here in the U.S. But we have 160,000 miles of track. That's plenty of space to locate your business on, and as long as those little spurs that are connecting into the main lines are, more actionably serviced and more reliable for your deliveries, you can move your business to a warehouse along the rail lines, and that's going to encourage that modal shift even further and encourage the growth even further. But businesses have to have a compelling reason to do that. And right now, the speed of delivery in many cases with rail is what's limiting that from happening.
You mentioned that rail and road goes forward together. What about autonomous trucks in the US? How far is that technology?
Yeah, it's a great question. It's always 1 year away, depending on who you're asking. But autonomous trucking is certainly a space that was heavily developed. A lot of work has been done. A lot of businesses have grown and developed in that space. And it makes a lot of interesting sense when you're looking at the impact of the movement of those goods. And it's also kind of interesting because rail, when you look at a North American type of freight train that might be 2 miles long, the autonomy doesn't really matter in that scale. It matters when you start to get down to one rail car that has to get one customer. And then when you look at the things that autonomous trucks struggle the most with, it's things like, how do I navigate a GPS environment that isn't a clear line of sight? And how do I navigate an environment with randomness? And rails inherently, by accident, set up well to solve those problems with physical infrastructure as the guidance system, with a central controller and dispatching, such that Alex and I can't just get in our tugboat and drive somewhere without the network knowing. And all those types of advantages that rail has means that we can adopt these technologies faster, quicker. And the question of why wouldn't we do this first is very logical. And that's one of the reasons why we're excited to be innovating here.
Great. So we talked now a lot of innovations and about some potential solutions for the future. So then let's jump to your company, to Intramotive. But maybe before, it's a rail tech company, obviously, but before we're getting there, so maybe Timothy and Alex, can you just give us like a brief overview? Who are you and why you decided to go to the old market of or the old business of railway?
Alex and I grew up together and have a long relationship since we were kids. But my background generally is engineering. I did undergrad in mechanical engineering, did a PhD researching jet engines, and I spent most of my career in the defense industry working on things like cruise missile platforms, fighter jets, and then leading a team of engineers building urban air mobility platforms for things like flying cars, which are electric motors, batteries, sensors, all fused together to build a vehicle that's focused on packetization of either people or cargo. And then 4 years ago, longtime friend Alex here came to me and said, hey, I'm doing case studies in supply chain logistics, looking at rail, and curious what happens if you take all those technologies you're building and if we applied those to rail.
A little bit like the Hewlett-Packard story, right? Two friends just thinking about what they can do together in the future. It's great.
It certainly is a lot of fun to be at this point where I know when we were kids, we talked about different business ideas and different things we might want to do in the future. And now to have gone our different directions and have built something real now, coming back together from our first couch sled type of scenario, which I'll let Alex share about, to now another type of vehicle, which is very tech forward.
Yeah, for about 20 years, I've been piggybacking off of Tim's brain and engineering mind. So even back in physics class in high school when we did a group project and basically he built the entire trebuchet that we were supposed to build. But we also had some extracurricular stuff like slapping skis on an old couch that we found on someone's porch and then using it to sled down a hill, a local hill when it was snowing. So we go back a long way when it comes to working together on crazy ideas, and happy to be able to turn that into a career now, which is pretty fun and pretty unique. But my background is more on the business side of things. So I have my MBA and also spent some time in the Air Force doing air cargo logistics. So I have a little bit of connection to things that move. But we're both outsiders to the rail industry and have had to learn a lot on the fly, but also pull in a lot of amazing teammates that have come from that background to really support us and check our ideas and understanding of things and say, well, that's a great idea, but it probably won't work in the rail system. And that's been hugely helpful to us. But yeah, I'm one of the few non-technologists on our team at this point, but it's been an incredible adventure thus far and excited to see where it continues to go.
What's the name Intramotive is all about?
Yeah, I can take that one. So we really wanted to think about how do we put some of these technologies onto the rail car itself. That was the initial thesis, that we maybe didn't need a locomotive to pull around huge strings of cars anymore. And what does that technology on the car itself enable? And that's where we went down this path of iterating around short trains, single carloads being able to move themselves independently. So the name really talks about putting the motive power from the locomotive and putting it into the rail car itself. And then the EV, the weird spelling of EV on the end, just a nod to wanting to be 100% battery electric and zero tailpipe emissions with our vehicles.
What is your approach with Intramotive to shape the future of the rail industry?
I think from our perspective here, we see a future where we really don't want idle rail cars. We don't want diesel moving those cars. or being consumed in the process of movement of our goods. And we think that by putting the motive power directly into the rail car instead of relying on the locomotives, we can enable the freight to move itself, get that point-to-point independent flexibility, and no fossil fuels necessary to move it. And really, it's just tying back onto that theme where we want to take what the rail industry does do so well today, drive more carload volumes through rail, through better technology, and then ultimately keeping the shipper's need in mind. So when you get to a train that has 2 miles worth of cars in it, every single one of those cars has to get somewhere. The expectation that the shipper has is visibility, is time, is speed. And we want to keep those customers in mind with what we're developing and as we go forward.
Yeah, and you talked a little bit about, I know Parallel was your kind of first guest on the podcast, so I'm sure your listeners are well familiar with them and probably are wondering kind of what the differences in our approach is. We're taking an approach of being backwards compatible with the existing rail system. So retrofitting existing rail cars, for one, there's just a market advantage to that with 1.6 million rail cars in the fleet in the U.S. alone. They last up to 50 years, so there's just this huge pool of assets that is being underutilized and sit around oftentimes up to 1 million of those 1.6 million a day that potentially don't move. So our approach is to keep the couplers, keep the air brakes, keep the hand brakes, everything that is sort of required to make it a rail car, but add on top of that. And so that's kind of our approach and how it differs. And we envision this future of long trains being very efficient today. We don't need to replace those. We don't need to replace an LA to Chicago type of route, but Chicago to Gary, Indiana, where, you know, that car, when it gets to Chicago, may sit for several days or even a week, to be pooled into a train long enough that is profitable for the railroad to move, to take it to a Gary, Indiana, or a Milwaukee, or wherever it is. That's where we envision the ability to depart autonomously and finish that last leg of the journey, to be able to better service customers and grow the rail industry.
So basically, you're taking like a conventionally a railcar, you upgrade the railcar with sensoric and autonomous capabilities, and then you basically doing the first mile or like the extended first mile, but you integrate this wagon into the long haul in the, let's say, traditional setup with locomotive and a lot of wagons. And then when you arrive like at the one hub, then basically you're going to do the last mile, again, autonomous. So it's an integration of two systems.
Yes, definitely. So that's the long-term vision. I would say another area where we kind of depart from the parallel model to our knowledge is the markets that we're going after first. So, looking towards that long-term vision, that's what we want to achieve. But we see this opportunity for many of these small point-to-point routes, whether that's at a steel mill intraplant going from one building to another with captive cars, or like our first customers in the mining industry where they have an insular rail route where it's disconnected from the rest of the network. And we can replace their operations there and make them much more efficient. So those are the types of use cases that we're going after first, and allow us to kind of not rely on the regulated rail environment first as the initial customer set and use cases that we're going after.
Okay, so you already talked about the use cases. So you do have already like one customer or even more where your upgraded wagons are already in operations.
Yep. So we've got one customer set now in Southwest Pennsylvania, where the cars are running now, getting around 1,000 miles a week put onto them. And then we have a second customer deployment set up in northern Michigan. It's a calcium mine where they're doing a first phase deployment this summer, looking at the replications at those same sites as well. And it's really the differentiation of the two products as well. So just as a technology layout, we've got this concept that you laid out where we can do a spoke, run the car itself to a hub, integrate that together. And that is that long-term vision where we're deploying these cars now. The Southwest Pennsylvania facility is a revolt use case where the vehicle we build collaborates with the engine. So you have an engine up front. There's 38 cars in that train. We convert a percentage of them, started with 3, to electric-powered cars, and that system works together. So the engine is up front, is relaying commands to the trailing units, which are slaves to that master unit, and then they can throttle power, and what that does is it hybridizes the whole consist. So it takes load off the engines, allows the rail car to push, to do things like attack grades, and then it regeneratively brakes itself. So it never has to be plugged in, it never has to be charged. And for that use case, again, if you have a 38-car train or a 200-car train, you don't want to have these giant extension cords running everywhere to plug these in. So the revolt doesn't have to be plugged in. And that's really that middle mile type of use case. And then for the Michigan deployment, that's the fully self-propelled and autonomous rail car, again, operating with other rail cars in that network and other tugbolts, but allowing that point-to-point motion and movement of calcium in that case. And that car can also pull regular rail cars with it. So this last mode of the Intramotive product platform and the tugbolt is named that because it's a self-propelled rail car that can pull regular rail cars with it, generally around 5 fully loaded rail cars with it. And in that case, at that mine in northern Michigan, we have 1 tugbolt, each pulling 1 regular rail car, which is the optimum for their tonnage needs, their route, their grades, their recharge cycle, and everything else that goes with it.
So there are more or less 3 product stages. That the one is that you're just generating like electricity while braking, which you can use then to speed up and to push on the one hand. The second one is basically that you have a point-to-point service and the integration like in a normal train. And the third one is that you really drive fully autonomous, self-propelled, and can also carry normal wagons. So basically a little locomotive at itself, the wagon who pushes conventional rail cars as well.
Yep. And that last mode that you noted is a little engine. What that does is it gives you the unit economics of these 2 and 3 mile long trains, but now with 1 to 5 cars at a time, where you can really granularize the movement of the goods, what you need where, and not see a massive increase in the cost associated with that.
I like the approach very much because whenever I explain it back in Europe about our challenges in the single wagon load transport, I always explain it like with an example like from the aviation industry. Basically, also for the feeder trains, we are using like big aircrafts, and then we are quite surprised that it's super expensive because one diesel engine can tow like 20 wagons or just 1 wagon. And if you just tow 1 wagon, then the unit costs are incredibly high. And I think that's something which you would then solve with having an upgraded car. So I like it very much. And can you just, from a point of what maybe some of us would be very interesting, can you give us a little bit more insight about which sensor and technologies enable these autonomous freight operations?
So from the whole tech stack, really where we're at is we use AR standard freight equipment. So we modify the truck sets, we modify the car bodies to allow for the storage of our batteries, to allow for the mounting of our motors, to the integration of our sensors. Things like battery chemistries on the vehicle are really exciting because our third co-founder, Corey Vassell, the CTO, he was in charge of trying to help us size some of these urban air mobility flying car systems. And the battery technologies there are still 40 to 50 times less energy dense than diesel. It's a massive challenge when you have to fly. However, when we start to look at packetization on rail and the efficiencies of rail, the low rolling resistances, the platooning, the aerodynamic drag benefits, he was able to size us a system, the first system he sized, which was 600 miles of range for a 100-ton payload. That's really, really exciting, and it truly showed that we were into the right space for today's technology space with batteries first. Then from there, the power systems, the motors, there's been a ton of excellent development from the auto industry, from other industries that are building small, high power, high torque motor systems, motor controllers, and the architectures for those. And we're adopting those, again, in that mindset where 1860, maybe the smallest engine was a steam engine. And now we're looking at power systems that the torque in a handheld drill is really amazing what you can get out of that system. And you scale that to what we need it to be for these rail cars. And then from the sensor perception side of things, we've got LiDARs, radars, cameras fused together running on these vehicles. In all of our first use cases, we can train the AI and the control system directly to the route. So when we're running a certain section of track, we know exactly where that track is. We know the GPS points. We know the elevation. We know the approved speed profiles, and we can geofence that off a GPS reference point to then cross-reference what the vehicle wants to do with the sensors coming off of the camera system, LiDARs, etc. Let's say this section of track should be clear. We do have the authority to proceed from the dispatch. And if anything is unusual or different from that baseline, we know to stop. And then from there, we can use reinforcement learning algorithms to say that we never trained our system to detect a hot air balloon. We know that it detected something, it stopped, and now we can use a reinforcement algorithm to say that that was a hot air balloon and it made the right decision, or that was a wild animal or something else that just looked unusual.
Okay. What I would be also interested, like not even Matt, but also all the guys in Europe, starting from Hyperloop, starting from Nevomo, we all faces like a big challenge in terms of cooperating with authorities with self-autonomous driving, because this is simply something which is not incorporated in the current rule set. So what is your experience? Is it super hard? Is it much more easier if you have an island infrastructure? So what is your experience and how far you are there?
Yeah, so certainly the infrastructure is one piece. The regulatory environment is another. The regulatory environment has to respond to the technologies that are coming. And that's where we want to be a part of the conversation. And we want to do it by deploying to all these first unregulated use cases. So the federal government in the U.S. has a section of rails that are deemed insular. And those are effectively unregulated rail routes, things like plant railroads, a lot of these mining operations, where we can go collect all the data, says that this is safe and reliable, and we can go to that regulatory body with the conversation around, here's our operating history, here's what we've been doing, here's the key things that we have learned or know about the safe operating parameters for these types of vehicles, and here's the data we can give you to be a part of that conversation and answer a lot of the questions that are the right questions to be asking, but you can't answer confidently without the data. So we're collecting that data, we're generating that for these use cases as well as on our own, and then going with that package to say this is what the regulatory environment should look like. And then in addition, there has been some great work in the self-driving space for passenger vehicles, for semi-trucks, and a lot of the work there is directly applicable. So when we're trying to look at how do we certify a battery power system for crashworthiness, we know generally what that needs to look like, and we can go to a regulatory body in rail that maybe is not used to working with that and say, this is what the auto industry is doing, this is what all of our testing has shown is necessary, and this is a starting point for us to have those conversations with.
For a lot of people, it's quite difficult to understand is why in rail, where you have tracks, should be more complicated to get authorizations rather in comparison to the road. So in theory, it should be the other way around, but I think the reality shows that it's sometimes not. And that's great that basically you don't reinventing all the stuff. So you take a lot from the automotive industry, as far understood, to put this together. And that would be also like maybe to you, Alex, a question like, how is the team of Intramotive? You said you are the one of the only guys who is not an engineer. So basically, is Intramotive more a software company or an asset company? So can you a little bit describe the size how many people working there, where you're working?
Yeah, absolutely. So we have about 35 teammates at this point, with plans to grow about 10 over the next few months. And so we're a growing team and a lot of interesting backgrounds from a lot of different areas, but yeah, mostly centered around that technology piece. So I'd say the split of kind of hardware and hard tech to software is about 50-50, or maybe pushing into software being the bigger team at this point. But that is with all of the technologies that we're kind of fusing together here, it is really all held together by software. So that is, we are definitely a tech company, and we're definitely engineering heavy. So right now it's basically just me and one other on the business side of things, and a few technicians that are considered definitely still technical teammates, but very much more on the assembly side of things rather than the design side of things. And so it's a great team, and we've pulled in people from a lot of different backgrounds. So I mentioned the rail piece. Our chief engineer, Adam Strachan, worked on the Rio Tinto Auto Haul project in Australia. So great experience to have with the 15 years of experience in rail to kind of, like I said, keep us in check and keep us in line. And a lot of folks from automotive, aerospace, and industrial robotics and automation as well. So we have sort of this fusion of ideas from all these different industries with the state of the art of these technologies that with the sort of aspect or presence of people with a lot of experience in rail and some great advisors from the rail industry as well on the operations side, that allows us to kind of bring the best of all of those worlds, but in a realistic way. We understand that we cannot, in many cases, shoot for the moon on what we expect the rail industry to adopt, but being a little bit more grounded in our approach and how we want to bring new technologies to life in the rail industry.
But Timothy know how to construct rockets, so why not the moon? And I would be also interested into the starting and founding phase. You entered in a new industry, and I can imagine that the first years were like a roller coaster, or was it simple and let's do it? And from that on, the journey was quite smoothly.
Yeah, no pathway for a new business is straight, and there's always elements of doing everything everywhere all at once. And for Intramotive, the challenges have been really interesting, but also fun, because we're bringing a new technology capability to an industry that, again, has been incrementally improving since the steam engine, 1% to 2% per year. And they've consistently achieved that improvement. And now we're coming with a new technology stack and a new approach to how we think about movement of those vehicles. It really creates a scenario where we had to think very deeply about the value add that Intramotive can make and how we can fit into that ecosystem in a way that complements what the 200 years of rail history and legacy have done to achieve those improvements. And the Tugvolt and the Revolt are both those vehicles that have been designed with that approach in mind, where rail does a lot of things right. We want to help it to continue to do those things and find these pathways for growth. But
now the story sounds very flat and great. So what was what was the biggest mistake you did?
Yeah, there's a ton of examples of things that could be talked about from first conversations with customers. It's like when Alex and I first started this, our approach was not to build anything right away, but to go ride around on railroads with crews and learn about what they were doing. And I still remember telling one of the engineers our first concepts for how this vehicle would work while riding on an engine with him, and him walking me through how he actually does his job. And the engineer's name was Eddie, and he said, "Hey, those are cute ideas, but we're just going to break them. If you give us something different than what we're used to dealing with, if you give us something that you tell me I can only go 1 mile an hour with, it's just going to end up broken and on the side of the rails." And that was a pretty big aha moment for me, is thinking about how this system works. And then on the technical side, obviously I have an affinity for that and a love for that space. And there's plenty of conversations with teammates. The good part is we bring people from aerospace, automotive, and rail, and we can guarantee something cool is going to come out of it. Along the way, though, there is friction where we have a teammate with 30 years of experience building fighter jets going 1.8 times the speed of sound. And then you got a teammate that's coming from the rail industry who is thinking of 20 to 60 miles per hour. And they're arguing about how fast a sensor needs to process inputs and deal with the environment. And there is a real tension that can emerge there. And then there is a secondary aha moment for them where they go, oh yeah, we are going 60 miles an hour, not 1.8 times the speed of sound. We are processing in an environment where we're still on the track. And you find this middle ground where the best in-class technologies can rise to the top that solve the problems at the right type of price point. And there is friction to get there. It's not a clean straight line all the time, but we have found consistent ways to get to that functional outcome.
Okay, great. Because normally, like, we always read the shiny stories, but for me, it's like even more important to see that it's a challenge and an adventure to go there. And adventure, Alex, from the business side of you, is your focus on business limited to the US market, or do you have already like also some vision to go globally or in other regions?
We definitely are looking globally. So, our very first focus has been kind of on the U.S. markets, just in the ease of being able to be on site and, closely involved in monitoring at every step of the way, the first deployments. But there's so much potential for our technology globally, even in the sort of these types of first use cases that we're talking about with the mining markets and the amount of mining rail that already exists in Australia, like we already mentioned, with some of the iron ore hauling that's going on over there, and the autonomous trains that have already set the precedent there, frankly, to be innovative and have a new technological approach. So those are markets that are very interesting to us. And, we talk about your market, the home market of Europe, the ability to enable short trains that can fit between potentially the passenger schedules that take priority there. So very different environment where you have a lot of state-owned rail, where the state owns the infrastructure and controls the scheduling and things like that, where there's preference for passenger schedules, and that is kind of the priority. It's very much the opposite here in the US of multiple stakeholders and priority for freight. So that kind of enables and allows those super long trains. I think there's a ton of potential in different markets globally as well.
Do you have any experience? Are there, for example, in Asia, some, let's call it competitors or kind of rail tech startups who is dealing with the same approach?
Yeah, there's passenger scenarios. So if you're looking at like airport people movers, there's self-propelled rail tracked vehicles for that. There's people that build power systems into passenger wagons for distributed propulsion. And there's certainly been other efforts in this space. I'm not sure about Asia in particular versus any other markets, but there's been pathways and attempts from autonomous trains running in Ohio in the 1970s, moving coal to Siemens, and they built a cargo mover that was a concept in the early 2000s. But really, the most important part here is that the time is right now. So the battery technologies are established, the sensors that we need to make this happen are established, the communications that we need are there, and we've proven it through these first deployments that we can go out, integrate all of these technologies that are necessary and safely deploy it. Where if you were still trying to use a lead acid battery system for this, or if you were still trying to use radio communications from the 70s with limited bandwidth, all of those things just really work against you to make this work as a system. So we're excited to be at that forefront at what we feel is the right time to bring these technologies and fully implement them.
We talked about a new technology stack of your railcars, and so how the railway would look like in 2050.
my initial take on it is it's pretty crazy to think that 2050 is only about 25 years away. And if you kind of think of that same time window looking back to the year 2000, say, and see how little has changed in the rail industry in that 25 years, obviously some new driver assist types of technologies and positive train control here in the States. So some good innovations there, but really just incremental changes and incremental improvements to the technology. So I don't think we're so bold to expect that at some point in that time, the switch will flip to suddenly the rail system looks like it was a greenfield built from the ground up operation with a total change in operational structure, but more that we envision these long trains and the current concept of operations to continue, but supplemented at scale by technology like Intramotives with the tug volt. So things that can enable new growth in the industry with interoperability to the existing way things are done and backwards compatibility to how things work today.
Yeah, I think that's a great look out inside the rail side. And I'm thinking outside rail, where in that same last 25 years, the world's drastically different. So if we look at political landscapes, we look at just expectations of what technology can and should be doing for us. And then we think of things like just ubiquitous adoption of touchscreens. The iPhone made a huge impact in 2007, but what that also proved was just the expectation of information and data being immediate, where connectivity is now part of our core. With things like if the internet is down, people start trying to remember how to do their work and do things effectively without it. Rail is kind of interesting to me because it's the physical embodiment of that connectivity. It's just movement of things over land. And I think on the logistics side, you've seen an explosion of growth in freight movement, but that expectation is similar with the information. People want visibility, they want tracking, they want speed, they want deliveries to show up the same day they make an order. And I think rail has missed out on a lot of the potential growth in the last 25 years because their tech stack hasn't changed that much. And when I look forward another 25 years, I'm thinking the rail industry doesn't have to miss out on another 25 years of growth. And instead, it's at this point where it can be the first industry to enable packetization, fully electric use cases, the flexibility in mind and a pathway that thinks, how do we look forward to growth and give that information, give that connectivity, give that immediate response that people have come to expect and think of in almost any other industry.
So basically, not really so these tunnels, Hyperloop or Storyline are much more like really to go further and to optimize quite much in speed, but also connectivity on the existing infrastructure.
Yeah, totally. I think Hyperloop's another interesting idea, a concept that has explored a problem space. But everything that we've learned is it's not about firing packages faster than the speed of sound through a vacuum tunnel. It's just about keeping the stuff moving. And if you're going 20 to 60 miles an hour, that's good enough. It's just when you're sitting for 4 days in a row, that really kills the movement of those goods.
Yeah, and that's, of course, eco-friendly because we know that a rail has a much higher energy efficiency than the road. Alex and Timothy, thank you very much. Having some insights from Intramotive. I'm quite excited what we can see in the future from you guys. And basically, at least from my perspective from Europe, I'm seeing you're already quite like on the top of the front runner of really doing the technology. And I personally love the yes, we can do mentality. Let's try, let's figure it out. And also to bring us various areas, like as you said, like from defense industry, aviation, or car industry, as well as rail industry together and make a good product out of that, or like an innovative product. So thank you very much for having you. And yeah, greetings to St. Louis, guys.
Yeah, thanks so much. Appreciate the opportunity to be on today.
Yeah, thanks, Sebastian. Appreciate it.
What is the contribution to drive climate change?
Yeah, we think the number one way is to ship freight movement from trucks to rail. It's a simple story from the energy efficiency of rail and the fact that you need less energy inputs. And then the new technologies around battery technology, around the motors and controls, really can drive the technical need of how that material moves to do things like in the U.S. here, 1% modal shift from trucking to rail will make a massive impact, the amount of CO2 emissions. And in the cases we're deploying now, even just a simple use case of 3 tug volts moving calcium has a 12,000 ton CO2 elimination for that type of movement. And you start scaling that into all the movements that can be addressed with our technologies. And that's a huge impact to that bottom line of emissions.
The ball is in your court. What is the next step to drive change?
So we're taking the steps now to drive change by deploying into private and captive use cases first to prove out the technology. And from there, we really need rail regulators globally to adopt a framework that encourages the innovation necessary to drive the modal shift to rail and support all the political goals that are around those efforts.
Which superhero do we need to avoid the climate disaster?
We need to turn Thomas the Tank Engine into Thomas the Tugboat.
What's the takeaway from this episode?
My biggest takeaway is that heading the revolution in an industry doesn't necessarily mean inventing from scratch, but instead forming a motivated team out of experts across diverse fields to reimagine existing technologies. This is precisely what Alex and Timothy accomplished in the rail sector with Intramotive. The potential for transformative growth in rail freight hangs on the integration of innovative technologies and new strategies. Intramotive's bold vision of merging self-propelled autonomous railcars with traditional long-haul operation promises to change how we think about rail transport. The approach of starting with manageable short-distance services to build experience and showcase potential is a strategic move that is as smart as necessary. Furthermore, the retrofit approach enables usage of already existing and homologated rolling assets. I'm also deeply inspired by the story of 2 childhood friends who turned their sandbox dreams into reality. Both are aiming to reshape the global rail ecosystem, and this is the essence of what RAILUP stands for: ambition, innovation, and the power of collaboration. Welcome to RAILUP.
This podcast connects innovators and leaders worldwide to shape the future ecosystem of rail. RAILUP by Sebastian Sperker.